Hello, everyone. In this lesson, we're going to talk about one of the basic algebraic skills that we're going to use often in calculus, which is rationalizing the numerator. Well, of course, sometimes we do rationalize the denominator, but in this case, we mainly talk about rationalizing the numerator. So look at this, share the screen, okay? And in this lesson, because we're talking about this, this basic skill, so first we're going to talk about the why and how. Okay, the why. The why is that in some cases, right? In some cases, we need to manipulate algebraically to get something that is more manageable. Okay, that's why. And the next one is how. Okay. A typical question like the first one, for example, how do we rationalizing the numerator? Okay, so rationalize the numerator. In calculus class, you will learn why we have to do that, right? In this case, we want to rationalize the numerator because for reasons in calculus, we're going to do that. The technique we use, right? The technique we use is based on this algebraic formula, which is a root of a, no, not root of a, it's any a plus b multiply a minus b. This product, if you FOIL it, is going to equals to a squared minus b squared. Okay, a is any real number, b is any real number. So, and these two numbers are called conjugates. So these two numbers, okay, they are called, they have a name, right? We have a name for them. It's called conjugates. Conjugates. Examples of conjugates. Examples of conjugates. For example, if I'm going to have two columns, okay, we're going to have a couple of examples. Of course, a plus b, its conjugate is a minus b, right? They are conjugates to each other. So conjugates. And of course, conjugates are conjugates to each other. Oh, there are always two terms involved. When we multiply conjugates, we insert the third column, right? The conjugates multiply, we're going to get a squared minus b squared in this case. Another example, say, I can say is 4 plus 3. What's the conjugate for 4 plus 3? 4 minus 3. 4 minus 3. And 4 plus 3 times 4 minus 3. Okay, look at that. Multiply 4 minus 3. 4 minus 3 is 1. And that equals to 7. It is also equal to 4 squared minus 3 squared. And 4 squared is 16. 16 minus 9 is 7. Right, so it's true. Another case of conjugate, it could be root 2 plus, say, minus 5. What is root 2 minus 5? Well, the conjugate of root 2 minus 5 is root 2 plus 5. You can see we simply just change the sign and we will get is the conjugate. And let's look at the product, right? Root 2 minus 5, root 2 plus 5 times root 2 minus 5 is going to equal to, according to the formula, or your FOIL is going to be equal to root 2 squared, a squared. Oops, what did I do there? Okay, so let me do it over. It's going to be root 2 squared minus 5 squared. Okay, and the root 2 squared, of course, that's going to be 2. So that's how we apply that formula. That's going to be 2 minus 25. Okay, so let's look at some more examples. I'm going to insert a couple more rows. Okay. What if we have root 7 minus root 5? Okay, we can put it on this other side. It doesn't matter, right? Its conjugate is root 7 plus root 5. And the product, root 7 plus root 5, multiply root 7 minus root 5 is going to equal to root 7 squared minus root 5 squared. And of course, root 7 squared is 7, root 5 squared is 5, and that's going to be equals to 2. Okay, so now let's look at this example, root x squared plus 9, right? So this is minus 5, is the conjugate is plus 5. When we multiply these two, where I'm going to make the fonts a little bit smaller, right? So when we multiply these two conjugates, we get root x squared plus 9 multiply is the conjugate. One is a plus, one is minus, and that would equal to x squared minus 9. I'm sorry, x squared plus 9, right? A squared minus 5 squared. And what does that equal to? Well, root x squared plus 9, then squared, that's going to be equals to x squared plus 9, subtracting 25. And then in the end, we get x squared minus 16. Okay, you can see these are examples of conjugates. And when we multiply conjugates, let's do one more example. Is root 9 plus h minus 3. Its conjugate is root 9 plus h plus 3. And we apply the product of conjugates, right? And one is minus, one is a plus. And we will get root of 9 plus h squared minus 3 squared. And that will give us, 9 plus h in square root, and then squared, we get 9 plus h. And subtract 9. Okay, and in the end, we get h. you get H. So these are the examples of how conjugate works, okay? How conjugate works. And next, we're gonna see how we use the properties of conjugate to rationalize the numerator. All right, so take the first example. We want to rationalize the numerator. So we want to get rid of the radicals in the numerator. So one thing we can do is that we're going to multiply by 1. We understand that anything times 1 stay the same, right? I'm just making the font a little bit larger. Okay, so we're going to multiply number 1, but this number 1 is going to be chosen to be the conjugate of the numerator, which is root x squared plus 9 plus 5. So this the quantity we have in the numerator and denominator is the same. So this is 1. So 1 is replaced by a quantity that the numerator is the same as the denominator. So we multiply by 1. Anything times 1 stay the same. Therefore, we can justify the equal sign. And the next step, we're going to take the numerator times the numerator, denominator times denominator. Okay, so denominator we have x plus 4. We're going to put it in parentheses. And in the numerator, we're going to have root of x squared plus 9 plus 5. Okay, so the second step, right? The first step we multiply by 1. Secondly, we're going to do the fraction multiplication. And then the top, we're going to apply the properties of conjugates. Denominator stay the same. And the numerator, which is a minus b times a plus b, and that equals to root of x squared, right? Squared minus 5 squared. Okay, then equals to the next step, x squared plus 9 taken square root and then being squared, that will be equals to x squared plus 9. And the 25, subtracting 25, and the next step, and the top is minus 16 from x squared. Okay, and then how do we reduce from here? Well, x squared minus 16 can be factored. This can be factored. Okay, so x squared minus 16 is factored into x plus 4 times x minus 4. And then x plus 4 and x plus 4 will be reduced. So in the end, we'll get the reduced form, which will be without x plus 4 from the top and from the bottom. So we can remove the parentheses from the top and bottom, and that is the end of this question. And we no longer see radicals in the numerator. So the expression is called rationalized. And the latter is the same as the former. Okay, we have a couple more examples. Okay, you can do the following 2 examples by yourself. Okay, they're very similar. They're very similar. Okay, I'm leaving 2, 3 for you. You may like to work it on the side and come back to watch it over. So number 4. Let's look at number 5. Number 5 on the first side, we don't see anything. We don't see any radicals in the numerator, nor we only see radicals in the denominator, and we're asking you to rationalize the numerator. Well, as we reduce it, right, we will start to see radicals showing up on the numerator, because in a lot of the cases, we want to express the expression in factored form, and this is obviously not in factored form. We're going to do a sequence of factoring, right? The t, this can be written as 1 times 1 over t, right? So this expression is the same as this guy. So we're going to factor out the 1 over t. We're going to factor out 1 over t. And inside the parentheses, we have 1 over root 1 plus t minus 1. And then we're going to find common denominator for the bracket. And we just leave out the 1 over t. And to get the common denominator, so we have 1 plus t in the square root under 1 plus t in the square root. Now we have the same denominator, right? So we can combine these two in fraction. So we will get one fraction, subtract the other fraction. We have the same denominator. So that will become 1 minus that. By this time, the bracket can be removed because this is just a product. And this dot is not totally necessary, so we got this. You can see now we have the necessity in some cases to rationalizing the numerator. How do we rationalize the numerator? We just multiply the conjugate of the numerator, which is 1 plus root over 1 plus that root. So now we get to use the property of conjugate. Okay, we keep everything, numerator and the front, the denominator stay the same. Oops. And the numerator, we just multiply one numerator with the other. So in the end, we get 1 squared minus the root of 1 plus t, then squared. We have applied the properties of conjugates. And that equals to, continue, copy, paste, right? 1 squared is 1. 1 plus t in square root and then squared equals to just 1 plus t. Reduce it. Okay, open up the parentheses. We have 1 minus 1 minus t. Okay. Now, one more step. 1 minus 1 is gone. We have a negative t here. Negative t and the t that will reduce, so we have a negative 1 left. Oops. Wait. No, sorry. So we got, put it back here, right? So this is a minus t now. Okay, and I put it in the parentheses. And t reduced. And so we have a negative 1 we have a negative sign generated. 1 over 1 is a 1. So in the end, we got, you can write it this way. You can put a negative 1 on the top. And the denominator would just be root of 1 plus t multiply the other denominator. Do not distribute. Just leave it like that because we usually prefer factor form as a result. Okay, as a result. RESULT. Okay, result. And that's all. That's all. There's another example here. Then this one can also be, rationalized. And I will leave it for you. And if you have any questions, then please don't hesitate to reach out to me. Thank you for watching.